I'm happy to answer your questions as we go through the materials, so feel free to just type them into that questions box. Mira and I will see those questions immediately and be happy to address them. So what I intend to talk about is kind of using root cause techniques to find the root cause of performance bottlenecks faster in your apps. That hopefully will produce better app performance overall, and that's because you'll be able to solve those problems more rapidly. And it's not meant to require you to do any giant heavy lifting. Instead, there are popular products like dynaTrace, New Relic, and even Appvance has its own monitoring capability. And I'm going to show how those are brought together into one solution. What I often call the huddle is when business managers, engineers, and testers get together. You could think of these as the stakeholders for excellent performance in apps. And it's, I've just did a talk at the Agile Software Development Conference down in Orlando, Florida, where people were asking, so what is the overlap from, say, Agile software development methodology to DevOps? And I was telling them that, primarily the Agile methodology has been, the kind of the energy behind continuous integration and continuous development. But there's no reason to do those kind of continuous integration efforts unless you've got all of the stakeholders to come to the table, and that's what I call the huddle. So if you're working on a new app, or if you're working on an improvement to an existing app, and you don't have a business manager, an engineer, a tester, maybe a DevOps manager sitting at the table, chances are you might fall short of actually delivering an excellent end-user experience. And that's it's important to know that each of those people in the huddle are going to have their own issues that they're trying to solve by working together. So typical business manager, when Appvance has tested some company's app, the business manager says, look, we're in production, and performance issues in the app have slipped through our testing. How much risk am I at? And they're asking that at two different levels. I mean, they are probably at risk themselves in terms of their own career if they launch an app that has a lousy end-user experience. But also the company is at risk because, if you're a leading branding organization, like maybe you're in the consumer products area, and you put out an app that has your brand name on it, if that app doesn't deliver an excellent end-user experience, then it's not only the app that's going to suffer with low ratings, but it's also the brand itself. So the business managers are all about, identifying the business risk. But it also risks their own career. I remember at a very popular beverages company, that they had a really awful launch of an app that was in support of one of their marketing campaigns, and that was enough for the reputation of the business manager to have suffered enough that he's actually no longer even working for them. You only really get a chance at bat to deliver excellent app and user experiences once before you become kind of tainted with that bad performance. The engineers, on the other hand, are typically full of heart and compassion and stuff, and what they want to know is like, what caused the app to deliver bad performance, and how can they affect an improvement in it. So the engineer sitting in the huddle would typically ask, how can I get the app into like a steady state so that I can diagnose and solve the issue? So for them, what's important is to be able to kind of recreate in a way that is viewable the conditions that led up to the app delivering a poor end-user experience. And that's really difficult because, typically engineers will only learn about an app's failure, say a couple of hours or maybe a day later, and then for them to try and recreate the same condition that the database was in, that the app server was in, that your mobile phone or your web browser was in. I mean, all of that might have changed since the app delivered that bad performance. And so the engineer's number one goal is, how can I get that app into like a steady state? And then the tester, of course, the testers are typically full of heart and compassion as well, because they might have run across an issue in the end user experience of the app when they're testing it. And for them, what they're looking for is how can they communicate the issue to the engineers in a way that the engineers can solve the issue. It's one thing to open a kind of a bug report or a ticket, that's sent over to an engineer saying, hey, the end user experience didn't work. It would be another thing if the ticket contained really an explanation of what part of the app didn't work and the actual, maybe even the lines of code that might be the cause of the app not working. When I was at Apple Computer many years ago, the testers were typically also software engineers, and so the trouble tickets actually were opened with chunks of source code attached to them saying this is where the tester believed the issue is. So if you have a huddle like this with the business manager, the engineer, the tester, and the DevOps manager getting together, you have the stakeholders there. They each need a set of tools and methods to enable them to answer what their own needs are and do so in a way that solves the performance bottlenecks. So what I call continuous DevOps is an architecture that enables you to achieve that kind of huddle and make sure that the stakeholders within that huddle are able to turn to tools and methodologies that will allow them to complete their work. So you might not have heard of this term continuous DevOps before. It's just something that I thought made sense after spending so much time with continuous integration environments like Hudson and now Jenkins and Cruise Control and Bamboo. I've also spent a lot of time with deployment systems like Puppet. Continuous testing is pretty much what Appvance has been doing since the start. So if you put those three together, you have continuous DevOps. And what I envision is a time when developers, testers, and DevOps people all are working towards the common good of finding and solving performance problems in the end user experience of the apps. So here's an architecture that might work for you. So the graph that you see here on the left basically has these interlocking components of an IT system. So on the right, for example, you have a runtime box. One customer that Appvance had made an investment in an enterprise service bus. And that service bus basically moved messages from a web app to a series of back-end systems. So for example, if you wanted to find the store, the local retail store of this particular company, you could go to their website, type in your zip code, and you'd see in response which stores were located around your zip code. So in the runtime, there was an enterprise service bus that would receive the zip code from the web app. It would then pull a mainframe, and then it would respond back to that web app with the list of stores. If that while that transaction was happening, there was a monitoring capability built into the enterprise service bus. And this would work for pretty much any of the ESPs that are out there now. There are commercial products like TIBCO, and Oracle has its enterprise service bus. IBM has Process Director. Red Hat has the Red Hat ESB product. And you have other open source products like MuleSoft. They all have a runtime, and they also have like a monitoring capability built in. Now, some of them are more powerful than others. For example, the TIBCO system comes with a monitoring system called Hawk, which is just excellent. It'll observe how fast those messages are moving across the bus, and it will fire off alerts when those messages aren't delivered fast enough. So the monitoring capability in, say, TIBCO Hawk integrates directly with a ticket management system. If you're using Rally or any of the other ticket managers, then the monitor can open a ticket directly. But that's fine for notifying the rest of the team that there is an issue. This ticket would exist. That's the notification. But wouldn't it be much better if the ticket itself had some stateful information about what the system was doing at the time that this ticket was open? Well, this popular retailer that Appvance worked with also had us integrate a continuous integration environment, a test running capability, and a repository into this environment. And so it all made a beautiful loop. So when the monitor opened the ticket management system fired off a request through Jenkins as a continuous integration environment, saying, hey, I would like you to run a test at this very moment in time, and I will record the results of that test back into that ticket. So when the engineer or the DevOps manager or the tester eventually looked at the ticket, they'd also see the results of a mini performance test and a mini functional test that was executed against the part of the application that wasn't working. Pretty cool, huh? Okay, so, and I will only say that once. So the continuous integration environment, that would be Jenkins, is able to make a service call through a plugin to a test management platform, which in this case was using Appvance's Performance Cloud product. The test platform then operated both a functional test and a small performance test against the app, and it did it by matching together the tests that were associated with that part of the app, and those tests were stored in a source code repository, which in this case was Git. The test platform in this test box was then able to post back to the CI platform and then back into the ticket manager the results of the test. So when the engineer or the DevOps manager or the tester looked at the ticket, they'd not only see what the issue was that the monitor produced, but also they would see attached to it whether the app passed a functional test and also a performance test. So by integrating these continuous integration environments, continuous deployment, and continuous testing, you now are able to move the kind of the huddle of stakeholders up a very big step towards getting to the root cause of a performance bottleneck in an app. This system didn't take more than maybe a month to engineer, and there are plenty of service companies out there, including Appvance, who has consultants that could do this kind of integration work for you if this kind of system makes sense for you. And if you have some Java experience or some C or some other development language experience, I tell you, delivering this continuous DevOps architecture to your organization is really very straightforward and not complicated at all. Okay, so the reason that we do this kind of continuous DevOps is because we really want to kind of measure the success of the app. And so what I'm going to do is just cover why we're measuring success. And I'll tell you the reason that I want to cover this is because I think it's kind of made as an assumption by many testers that, like, oh, I'm just doing testing because it needs to be done. And instead, they kind of forget what the actual benefit is to their own organization. So I'm just going to be really kind of direct about the three areas of testing that I think are important to an organization and what the benefit is. So from my perspective, you have three. The first is functional testing. Basically, functional tests are there to define whether the end user is experiencing success in using the app. There are various things that could get in the way of that kind of success. So it could be that they're using a web app or an Ajax app, and the browser that they've chosen, like IE 6 or 7, is no longer compatible with that app. And so there are rendering problems, there are functional problems, maybe functions that used to work no longer work. It might be that the app itself is suffering from just really poor performance. So you press a button within the user experience, and that button causes one of those spinning disks of, to tell you that something is being processed. And, it takes 30 seconds or longer before the button completes its task. It could be that the end user, that person using the app, is just not willing to wait for that kind of latency of the user experience. And it could be that the functions are broken. It could be that in the app's deployment that there were configuration or integration problems. So that would be a case for functional testing. the solution for functional testing tends to be regression testing, system testing, integration testing. Functional testing, though, you could think of it as being a kind of a performance test where you're just having one user use the app once. A very small performance test. When you want to know kind of how many people the app is ready to serve at any given time, that's where performance testing is really beneficial to an organization. And so that business manager will ask, hey, how many people are we ready to serve? And the answer to that will identify the business risk to the organization to launch this new app or to launch an improvement of the app. So, the second area then would be performance testing, and then the third area kind of identifies what happens to the app when the app is dealing with many more users than were initially intended or forecasted. And just to give you an example of this kind of stress testing, there was an international bank customer of Appvance's that put out a set of mobile apps. These were apps that ran on iPhone and Android, and these were apps intended for the bank's high net worth individuals. So like if you had $1 million in the bank, then the bank would give you this special app that you could check your bank account information directly from this app. The information system behind the app was essentially an Oracle database using an in-memory cache system. And so what do you think happened when too many users started using the system? The cache didn't clear fast enough, and that meant that if you were logging in, you could potentially see somebody else's bank account information. That was disaster for this international bank. And so it was only really when they got to stress testing did they identify the experience of the end user, of the people using the app as the app fails. So of these three types of testing, which is the best? Well, I'd say all three of them are necessary. And yet what I find is that most organizations treat these three types of tests as though they're different, as though they shouldn't all be accomplished. And I'll tell you, what all three of these do are they're testing and measuring the business risk to the organization for a particular new app or for a change to an app. So it's not a question of like, do I do functional testing or performance testing? You need to do both. And do I do performance testing or stress testing? You need to do both of those too. As a matter of fact, there's a new category that's emerging called security performance testing. And that's because the hackers of the world have pretty much moved on from just doing simple breaks of like an app, at a functional level. Instead, they know that most apps will start functioning differently when they're stressed. And so they'll do kind of a denial of service attack against an app at the same time that they'll try and breach the app. And so security performance testing is kind of an extension of stress testing where you're running a security test of the function of the app, but you're doing it at stress testing levels. Okay, so
Frank, we do have a couple of questions real quick.
Go ahead, Mira.
So the first question is, aren't these kinds of tests best done separately?
No, not at all. So the issue there is that if you've already defined a test to do functional testing of an app, why create a separate or new test script to do performance or stress testing? You see, what Appvance has done over the years is introduced beginning-to-end testing. The idea is that if you already have a test at a functional level, there's no reason why you couldn't repurpose that to be a performance test and a stress test too, and also a security stress test. So what we would recommend is that you follow a continuous DevOps architecture that's going to have a set of test scripts kind of operating within that architecture, and that you choose a set of tools and an Agile methodology that supports repurposing those functional tests to be performance tests. And I'll tell you, many people, even last week when I was at that Agile software development conference, they were surprised when I told them, hey, use this repurposing system to repurpose a functional test to be a performance test. They were surprised. They're like, can you even do that? And what I explained to them was how you could do it using a set of open source tools or even the Appvance product. And it made sense to them. I think they were listening too closely to the old legacy test tool companies like HP with its LoadRunner product. You know, LoadRunner is great at performance testing, but HP will sell you a separate product, that's the QTP or Quick Test Pro product, to do functional testing, and those two products are not compatible at all. So once you write a functional test, you cannot repurpose it to be a performance test. And that's not your fault or your organization's fault. That's the fault of HP for not realizing that there is a continuous DevOps architecture that supports repurposing functional testing to be performance testing.
Our last question at this time is, how are performance monitors integrated with testing?
So the cool thing about performance monitors being integrated with testing is that you can now take a look at what the back end of the app is doing to support that app while the test is running the app through the front end of the app. And so that's kind of the next couple of slides will explain like how that loop is accomplished. Okay, so if there are other questions, feel free to just type them into the questions box in the GoToWebinar window, and Mira and I will see them immediately and be happy to answer them. Okay, so let's see, the testing strategy that I find works best for apps today really focuses around either testing web apps, you know, apps that might have, will most likely have AJAX components to them and are run in a browser, and that browser would be like Internet Explorer. Or they're mobile apps, you know, mobile being like either the iOS operating environment, meaning iPhone or iPad, or the Android environment. Or it could be a set of services, like say your app depends on SOAP or REST services provided by a partner company, and you want to test to make sure that that partner is able to scale up with your app. So in that light, what I find is that there are a set of kind of test tools that are out there that will test these kind of apps, these kind of pages, and these kind of services. And but it requires us to take a really close look at kind of what the capabilities are of those test tools and how they will plug into the test methodology that we've got. So one thing to note is that most of the apps today are being built around kind of a serverless architecture. That is, for a web page, once the web server delivers that page to the browser or to the mobile web browser, a serverless architecture means the page no longer has any sort of direct connection back to that server. Within the page would be a bunch of JavaScript or AJAX components, and those components would be making SOAP or REST calls to a number of different back-end servers. It might be the server that originally served up the page, but chances are it's not. It's probably going to be other servers that are from your partners or from different groups within your organization. And so those pages that are implemented with a serverless architecture probably have their own state, their own workflow, and their own communication protocols. By state and workflow, I mean that it could be that the app that's running within that page requires you to like kind of click through a bunch of tasks before you get to a point where you can test to see if that app is actually functioning correctly. So real-time analytics and an immediate fix are really necessary to be delivered at the same time. It means that you should be able to not only take a look at what the app is encountering in the browser, but also what's going on the back end of the servers that are responding to that page's requests. And to do that at the same time requires kind of correlating the monitoring to the testing. Now, I talked on the last slide about kind of beginning to end testing versus what I think HP has correctly coined as end-to-end testing. But I'll tell you, in this kind of environment where you're dealing with today's apps and pages and native apps for mobile, beginning to end testing is becoming required. if you look at where Load Runner was, say, 10 years ago, when the web was brand new and basically every page was just either a link or it was a form that did a form submit. Well, those days are pretty much done. If I go to Delta Airlines' website, for example, today, they've got a ton of AJAX or JavaScript functions running within that page. And if I don't actually run those actual JavaScript elements, then you're talking about a test of like the backend system over its native protocols and not a test from the beginning to end of the app. And that can mean that with all of your test effort that you still leave uncovered or untested the most important part of the app, and that is its function, its workflow, its state, and its communication. So rather than doing end-to-end testing, I prefer you to do beginning-to-end testing. With an end-to-end test environment like Load Runner, it'll observe the browser's communication to the backend, and it will mimic what those protocols actually are doing to talk to the backend. So typically it'll work at a protocol level, like using HTTP as the protocol. And when you play back the test, it will play back the HTTP request to the backend. But that means that it won't actually bring up the app in a browser. It won't run the app as an actual user or the person would. And that means that all you're doing is mimicking or testing what the backend is able to do to support that app. So it could be you deliver the app and it has terrible end user experience latency, but there you go. You tested the backend, not the entire app. So HP coined this phrase end-to-end testing, and that makes sense. There's a good time to do end-to-end testing, and that's when you're doing server forecasting and wanting to make sure the servers are set up. But I'd say that it's more important to do beginning-to-end testing. And to be able to do beginning-to-end testing means you need to choose a test tool that can actually bring up the real browser and actually operate the app as a real person would within that browser environment. And so obviously there are going to be some big issues to contend with, hey, how many browsers can I start up in this environment concurrently? Okay, so what I'd like to do is basically talk a little bit about kind of how application performance management, APM for short, would work in this environment, and where it's really going to be strong for you and where the weaknesses are. So let's consider that. There are basically two environments where application performance monitoring works well. One would be while the app is under development, and you're really there looking to see, well, what's the business risk to the organization for the app launch based on the monitoring that I'm doing of the backend systems. Are those backend systems provisioned well enough? Like, do I have enough CPUs? Did I buy enough network bandwidth? That kind of thing. Do I have enough memory? After the app launches, though, that's where I think using kind of a proactive APM strategy makes sense. So it could be that while the app is under development, that you run a performance test against it, and you run it, say, at 10,000 virtual users. Well, after the app launches, what I'd recommend is keep 100 of those virtual users running all the time. And I'm talking about all the time even against production. The actual overhead to the DevOps manager to keep those virtual users running is pretty small. Especially if you've tested at the 10,000 user level, chances are your organization is expecting that level of load. Well, an extra 100 virtual users running against that system is probably not even going to be noticed. And yet, it'll be incredibly important for the engineers and for the DevOps managers when they start to see these tickets being opened, indicating that there's an issue with the app's performance. That's because if you keep these 100 virtual users running continuously, if you're taking basically a proactive APM strategy, then that would show the DevOps managers and the engineers a benchmark to app performance that they could measure the app against to uncover where the performance bottleneck lies and how significant the performance bottleneck actually is.
Frank, we have a question. What is the difference? What is the difference between beginning to end and end-to-end testing?
Oh, okay. Well, beginning to end testing means that you're testing using the actual app environment. If that's a web app, then it's the actual browser. You're firing up the browser as part of the test. You're running the app in the browser, the real browser, and you're observing that the function of the app is correct and that the speed or the efficiency of the end user experience is there. Beginning to end testing means that you've observed the communication that's happening from that browser to the backend server, and you're going to mimic that communication when you run a performance test. But you're not actually operating the app from beginning to end. You're just operating the app from end to end, from the backend of the browser to the server.
Our last question is, do you keep those virtual users running for a baseline?
Yeah, the idea is that if you keep the virtual users up and running, like a small segment of them, like let's say you tested at 10,000 virtual users, well, keep 100 of them going. If you tested at 1,000 virtual users, then keep 10 of them going. If you just keep on doing this kind of continuous performance testing, then that becomes a benchmark to the app's performance that the engineers and the DevOps managers will love you for. I see one other question that came from Nadim. He says, the test environment never behaves in the same manner as the production environment, and we do not test in the production environment, so what is recommended besides using an extrapolation factor? So, Nadim, very good question. Very few organizations have made the investment in their test environment to be the same as the production environment. Normally, it's just too expensive, and there are too many different things to test, so it becomes kind of a question of picking and choosing what you're going to test. So what I would recommend is that you use your test environment to do the functional and performance testing, and that you provide that same information to your business manager indicating what the differences are between those two environments. If the business manager's input is what's the risk of launching this app, then at least you're going to tell them, hey, when we tested in the test environment and we were at, like, say, 10% of the resources that the production environment would have, meaning like if the production environment had like 10 CPUs and your test environment had 1 CPU, that's 10% of the production environment. Then at least it'll be up to the business manager to choose whether they're going to extrapolate out and multiply those numbers that you give them by 10. The other thing that I find with test environments is that they often don't have access to the same back-end services that the production environment has. So it could be that your production environment has, say, an LDAP service for doing login, and that's just not provisioned for the test environment. Well, in that case, using service virtualization probably makes sense. And there are plenty of tools out there. For example, Appvance has participated in the SOAP UI open source project from the start, and SOAP UI has a virtualization mechanism for virtualizing SOAP and REST calls that's very sophisticated and very easy to use. And so if you need a virtualization tier, then we recommend going in that direction. And Nadim, if I haven't answered your question entirely, then feel free to just type in another one in the questions box and we'll answer it. Anything else, Mira?
That's all we have for right now.
Okay, so I'm going to move on then. To see an example of how this kind of correlation can work, let's look at one of the Appvance performance reports. This is a transactional analysis of the test as it operated across the amount of test time that we gave it. So in this chart, we've got we call it a transaction distribution chart. It's measured over the time of the test, and we tested this app for 41 seconds. So the horizontal axis goes from 0 to 41. And then these little round dots are indicating when the tests were completed with their workflow. So the test in this case would log into an app, would click on a search button, and would and then would check to see whether the particular product that the test was looking for in the search results would appear. And so it took, let's see, just over 10,000 milliseconds or 10 seconds to operate this test. And then a second virtual user logged in shortly after the first user. And then you can see there was another like 10 seconds that went by before the same virtual users were able to perform that transaction again. Now, if any one of these transactions failed, we could click on these little round buttons and then see down here like the details around that transaction. So we could see specifically the HTTP request that the app was performing to communicate with the back-end server, and we can see what the app's state was as the test operated against the front end of the app. So what we did is basically added something. So if you click on any one of these little round buttons, little round icons, then you'll see the details down here below. And then you also have these buttons that allow you to click over to a popular application performance management platform called New Relic. New Relic's, pretty much kind of the young and up-and-coming kid on the block, challenging Oracle's Enterprise Manager and IBM's Rational Tester, Test Monitoring, and TIBCO's Hawk, and all of these other things for monitoring. It's delivered. New Relic is delivered as a service. So when I click on any of these things, all Appvance needed to know is what was the time index into the time that this test or this transaction actually operated. So if I click here under the app server, then what I see is a New Relic page, which comes specifically from my app server, and it's going to show me all of the details that New Relic has been observing within that app server as that test was operating. So you could think about it as this screen is showing us what the app under test looks like, and this is showing what the server responding to those apps requests is looking like on the back end. So New Relic does observations of things like memory and CPU. It can identify how many instances of this app are running. It gives you all of the typical kind of system monitoring for threads and processes, both system as well as user processes. And then I can also set up New Relic to do transactional monitoring and browser identification. So if, for example, I notice that I'm getting different performance from my from a particular version of a browser, then great. I'll be able to monitor that and see if that's making a difference from New Relic. But if we're doing beginning to end testing, chances are that the test results here, which are showing me actually how the app operated, from the front end, I'm going to see whether the back end is causing any of that latency within the app. And that's incredibly valuable. So the cool thing about marrying these two technologies together, the test of the app to the monitoring that New Relic does of the back end of the app, is that I can find the root cause of performance bottlenecks faster. I mean, now when my developers or engineers take a look at the trouble ticket, they're able to click through into the performance results of Appvance operating those, say, 10 or 100 virtual users continuously, and that'll click through into New Relic's information to show them whether the backend was going crazy in some way, like the CPUs were up at 100%, or maybe the database was thrashing through my hard drive or something like that. Those engineers that are part of my Huddle will now be able to see exactly what was going on the back end correlated to what the test was doing in the front end of the app. So that kind of a correlated drill down with New Relic's APM is really kind of a refreshingly new way of identifying the root cause of performance bottlenecks. The other thing is, these are like simulated or virtual users. Well, you could dial up or dial down the number of virtual users after the trouble ticket is open. The same virtual users that are running could easily be expanded to go up to, say, 1,000 users just for, say, 20 minutes and then go back down, and that would tell your engineers whether they've got a problem in CPU, network, memory, or maybe the database query is running particularly slowly when we get peaks of users using the app. So there's about 15 different reports from the Appvance results repository. There are probably about 20 or 30 from the new Relic APM system. And so when you combine the two of them together, you've got this wealth of information that's all live, and it's also available to your developers without you having to do any special prompting. So with that, why don't we take a look and see if there are any other questions? And Mira, you might be on mute because I'm not hearing you.
Hi, Frank. Can you hear me now?
Yes, I can.
Okay, great. The current one question we have is, does this work with all New Relic versions?
Yes, so New Relic's been around now for 3 or 4 years, and they've constantly improved their product. And one of the things that they did early on was to define that any of these pages have like a permalink. So that's the integration from the Appvance platform to New Relic is through that permalink system. So any of those permalinks work correctly. They've worked correctly for the past couple of years, and they will work correctly into the future.
And the last question at this time is, what kinds of testing does this work with?
I'm sorry, Mary, you dropped out. Could you say that again?
What kinds of testing does this work with?
Oh, well, this works with functional testing, performance testing, and stress testing. It's all of those that that I listed out earlier, and plus, if you can use the same technique for part of your regression testing, integration testing, security testing. It's basically all of them. I mean, at this point in 2014, there's no reason why you shouldn't expect this kind of APM integration with simulated virtual users operating against the app. It's just that straightforward.
That's all the questions we have at this time.
Any other questions?
That's all the ones we have at this time.
Okay. All right, thanks. So basically, let me just give you a quick rundown of the New Relic integration. Basically, with New Relic, you can select any New Relic report. You can select a transaction within that report. You can see the report on like a server or a particular app or a particular database. It adds the New Relic monitoring capability to your app server, to your database server, to your load balancer, or to your Node.js server. And this approach is completely compatible with the tests that you might have already invested in building. For example, if you have Selenium tests or JMeter or Sahi or Appium, all of those tests are compatible with the Appvance Performance Cloud. So Selenium comes built into Appvance Performance Cloud, same with JMeter. And if you've written tests in a higher level language like unit tests written in Java or PHP or Perl, all of those are compatible with Appvance as well. So there's an easy integration then from your testing in Selenium to New Relic using the Appvance Performance Cloud product if you want. Or you can figure out how to do that kind of integration yourself, and there's lots of service companies and architects and engineers out there to help you along with it. Okay, so the thing about New Relic is that it does a good job at observing or monitoring what's going on the back end of your systems. But there are going to be cases where you're going to have a question from one of your engineers about the kind of path that a request took through your app and through the various different systems of the app. So in that banking application I talked about before, it could very well be that that app running on an iPhone makes a RESTful call to a backend server that talks to an ESB. The ESB then talks to a database, and then the database responds and through that ESB back to the app over a REST response. Now, there's like probably 3 or 4 levels of architecture to that app's operation of a function. Well, wouldn't you like to know kind of what the path was that was taken through all those different systems to be able to identify whether that path is the cause of a performance bottleneck or a functional issue? Well, to do that, what I'd recommend you do is take a look at dynaTrace. which is an app. It used to be its own company, and now it's part of CompuWare. dynaTrace has this technology called PurePath. Basically, they install agents on your web server, on your app server, on the load balancer, on the database server, and those agents are going to basically correlate the requests that an app is going to be making to fulfill a particular function. So what I did in this case was to monitor the WordPress publishing environment. Many of you, I'm sure, know about WordPress. It's basically like a blogging tool where you can create blog websites where people can like post their blog entries to. And so what I've done here is to take a look at the post command. Basically, the browser has made an HTTP request to WordPress/wp-commons-post.php, and what I've noticed is that the performance of this particular post is way slower than all of the other ones, and that's what these bars here. This breakdown is showing me how much time it took for the CPU to process that request and how much time was spent in I/O, either waiting for the disk to respond or in waiting for a web service to respond. So what I can do is click on this entry, and then down below it's showing me the PurePath tree. So here is the web request coming in. Here's how the web request is handed over to the PHP environment, and then here are all of the SQL queries that were executed to respond to that PHP execution. Pretty cool, huh? Well, this is fully integrated with that Appvance Performance Cloud product. So if Appvance is running a Selenium script that's talking to a browser that eventually that browser makes the web request, then you can go back to the Appvance environment and say, for this particular virtual user, show me the PurePath all the way through to the database and tell me where the latency was. You know, what was taking too much time? Was it a query that was taking too much time? Was it the database's disk subsystem that was taking too much time? Or maybe it was in the app server itself, like the request through the PHP tier. And so this will show you what the contribution in terms of time was to execute all of those queries and to execute the functions that were needed to respond to this web request. Okay, I see we only have another few minutes, so what I wanted to do is just call for questions. If you have any, just type them into the questions box. Otherwise, I'm going to show you a little bit more about the dynaTrace integration and then talk about Appvance's monitoring capability, and then we'll wrap it up. Are there any questions, Mira?
Hi, do you have, what is the difference between dynaTrace and New Relic monitoring?
So New Relic tends to focus on high-level resource monitoring. It's kind of like how much CPU am I using on the different servers that are running my database? How much network bandwidth is being used for the load balancer to talk to the app server? That kind of high-level monitoring is what New Relic's strength is. dynaTrace is really focused around those PurePaths. It's like identifying what the contribution is in terms of time as the app is responding to, as the backend systems are responding to the app's requests. So that tends to be the difference. And you know, what I'd recommend is, if you can afford it, to get both. Neither one is a particularly expensive solution, and you know, in the best world, it would be to get both plus Appvance, so that you could have this fully integrated environment where you're able to see the virtual user performance through the front end of the app and New Relic and dynaTrace's response or monitoring or APM monitoring of the backend.
That's all the questions we have at this time.
Okay, so any other questions, Mira?
That's all the questions we have at this time.
Okay, that's great. So there is one other thing you should know. If you do choose a high-level tool like Appvance Performance Cloud, it comes with its own monitoring in addition to what you can get from New Relic and from dynaTrace. As a matter of fact, most of the test platforms now have some sort of monitoring kind of built into them. And so this is kind of a checklist then for you to identify when you're choosing a test tool that matches up with your testing methodology and your APM methodology. So the Appvance Performance Monitor comes with the Appvance Performance Cloud. It is something that you install either on a load balancer, a web server, an app server, or a database server, and it's going to do these three things. It'll do hardware monitoring of, at a minimum, of CPU, network, and memory utilization. But it'll also do database monitoring. So in the case of Oracle, it will monitor things like how many table scans have been executed, how many resources were needed to compile the particular schema that of the requests that are coming in. It'll do the same thing for MySQL as well and other relational database products too. The third category of Appvance's monitoring is around the web app and Java monitoring. So this is a case where you would install the Appvance Monitor as a WAR file into your Java Enterprise app server, you know, like Jetty or a Glassfish or a Tomcat or something like that, or JBoss. And it will observe things like thread usage, garbage collection statistics, and heap management. So it could be that the garbage collection is causing the biggest slowdown in performance of your app at a Java level within the Java web app tier, and this is a case where the Appvance Monitor would identify what those issues are. Okay, so we have like 3 minutes left, and I wanted to give you just a quick roundup of what we've talked about. So we did talk about techniques and tools and methodology that are available to find the root cause of performance bottlenecks faster. It's combining application performance management tools with the testing capability of being able to drive an actual app from beginning to end that will produce better performance it'll produce solutions to your performance problems better and faster. We showed how you can do correlations from the analytic reports from some of these tools so that you can start with what the virtual user is seeing of the app's function and performance, and then click through to see what's going on the back end using popular tools like dynaTrace and New Relic, and even the Appvance Performance Monitor. We also showed how you could use these same tools to simulate the use of your resources like CPU, network, and memory utilization, the database query capability of your backend systems, and the Java capability of your backend systems. And we showed how you can use the Appvance environment to do deeper root cause analysis. So what I'd like to leave you with is if you're wondering, you know, when you build these modern apps and you're wondering how risky is that app launch going to be, give us a call. Our phone number is 855-254-1164, or you can send us an email at sales@appvance.com, and we'll show you how. So that's the end of the presentation, and we're happy to take your questions. Mira, what do you think?
Well, thank you so much, Frank. That was really great. And thank you, everyone, for joining us today. If you have any questions, please feel free to email us at sales@appvance.com. We have lots for you at appvance.com. You can receive a free demo